In this video, we will try to learn a scalar triple product. To learn about a scalar triple product, first we have to know about the parallelepiped. What is the parallelepiped? Parallelepiped is when the all face is parallelogram, then we call this parallelepiped. Parallelogram is two-dimensional, but parallelepiped is three-dimensional. There are 6 faces and all of these faces are parallelogram. Find the scalar triple product of this parallelogram. That's why we take an vector about this edge and this vector is called a vector. Then we take the another vector in this edge and this is called b vector, and then we take another vector and this vector is called c vector. So we take the 3 vector according to the 3 edge. Now we find the value of b cross c. This is b vector and this is c vector. If we cross multiply b cross c and we take the another vector and this vector is perpendicular to this plane and this is b cross c. If we all know r, if we find the value of b cross c, this is none but this is the area of this parallelogram. In this previous lecture, we learned about B cross C is the area of a parallelogram. Now we draw a perpendicular according to this face and join to this and this is called ace, and then we join to the base to this perpendicular. Now imagine this angle is theta. So this angle is 90 degree. So we get this angle is 90 degree minus theta. This angle is 90 degree minus theta. In this triangle, we apply the triangular law. We know that sine 90 degree minus sine 90 degree minus theta equals to perpendicular divided by hypotenuse. So perpendicular is a and hypotenuse is a. Sine 90 degree minus theta equals to cos theta equals to a divided by a. So if we multiply a into cos a theta, we get a is equals to a cos theta. The volume of the parallelepiped is surface area into height. So surface area is b cross c and height is a. So volume equals to b cross c dot a cos theta, because height a is equals to a cos theta. This is none but this is the a cross b dot a. So we can easily told that the volume of the parallelepiped is a scalar triple product, and this is a scalar Rashi because b cross c is a scalar. If we dot vector to vector, we get a scalar product. Then we have to prove about an scalar triple product a cross b dot c equals to this determinant. So let imagine that there are 3 vectors, a vector, b vector and c vector. So a vector equals to a1i plus a2j plus a3k, b vector equals to b1i plus b2j plus b3k, then c vector equals to c1i plus c2j plus c3k. Then prove that this scalar triple product equals to this determinant. So first a cross b dot c equals to, we know that a cross b, if we cross a cross b, we get first we have take the I j k, then we put this value a1 a2 a3 a1 a2 a3 and b1 b2 b3 dot c. We get I, first of all we take I, then this line and this line is crossed and we take this determinant of 4 a2 b3 minus a3 b2. In this way we can take of this value. Now we dot into this to this. If we dot, we get a2 b3 minus a3 b2 dot c1 in this way. So now this and this is same. Why? Let's see. C1, you get the C1. When you take the C1, this line and this line is booked. We take the 4 determinant. So C1 equals to C1 dot A2 B3 minus A3 B2. When you take the C2, this line and this line is booked and we get A1 B3 A1 B3 A1 B3 minus B1 C3, and we call this and this are the same. This is all about my lecture. Bye bye, take care.